In this video, we're going to have a look at some of the different interrupts available on PolarFire SoC's Platform Level Interrupt Controller, or PLIC. To view the interrupts available on the PLIC, in any of the bare metal example projects, open the platform folder and then the MPFS HAL folder. In here, you can find the MSS_plic.h file. This file contains the handler declarations for the MSS PLIC interrupts, along with the list of the interrupt numberings on the PLIC. At the top of this file, there's an if ndef sci5 unleashed, which is undefined in this case as we're running on PolarFire SoC. So down here, we've a list of all of the interrupt handlers that are available for us to use. You can use a specific interrupt by including one of the interrupt handlers defined here. For example, if we were using GPIO2 bit 31 as an interrupt source, and we want to provide an interrupt handler so that we can deal with the interrupt when it occurs, we can create an interrupt handler with the same name as defined in MSSPlic.h that will deal with the interrupt when it occurs. In this case, when an interrupt occurs, we'll print a message over UART and then set a GPIO output bit. Then we'll return keeping this interrupt enabled so it can occur again. Each interrupt can have its own interrupt handler, and all of the handler names are listed off in MSSPlic.h. If you scroll down a bit further in this file, you'll be able to see all of the interrupt numberings that are available. Each of the interrupts has an offset, which is defined up here at the top as a value of 13. This value is then used to offset different interrupts. So for example, this GPIO0 bit 0 or GPIO2 bit 0 PLIC 0 interrupt is defined as interrupt 0, plus the 13, which is the offset to the MSS global ints, which means this is interrupt number 13. This means when an interrupt occurs and we poll the PLIC, it'll return a value of 13 to let us know that the GPIO0 bit 0 or GPIO2 bit 0 PLIC 0 interrupt occurred. There are several interrupts available for different aspects of the system. For example, up at the top here, we've several interrupts available for ECC on the L2 cache. We have interrupts for the DMA controller to let us know that a transaction is completed, or if there's been an error, and we have these for all of the channels in the DMA. Then we have several interrupts for our GPIOs. Let's use the GPIO0 bit 0 or GPIO2 bit 0 PLIC 0 interrupt as an example. This interrupt can be configured to assert if GPIO0 bit 0 toggles and causes an interrupt, or if GPIO2 bit 0 toggles and causes an interrupt. This is configured using a controller and a mask. The controller is the sysreg GPIO interrupt fab COR register shown here. Information on the mask values that can be written to this register are in the MSS GPIO.h file. If we open up this file, on line 152, you can find a table that describes the different mask values you can write to the GPIO interrupt fab controller register. Each bit in this register represents a different interrupt on the PLIC. So for example, if bit 0 is unset, then GPIO0 bit 0 will trigger an interrupt, which is this interrupt bit here. But if bit 0 was set, GPIO2 bit 0 would be able to cause the interrupt. So, in the case of this example, we wrote all Fs into the GPIO interrupt fabric controller. This will select all of the GPIO2 interrupts as the interrupt sources on the PLIC. We've several interrupts for all of the GPIO bits that are available for GPIO0 and GPIO1, which could also be GPIO2. And then apart from the GPIOs, we've all of our peripheral interrupts listed here. For example, for SPI, for CAN, for I2C, for the Mac. For our DDR training status, for our ECC errors, for our RTC, for our different timers, our ENVM, QSPI, USB, and our MMC and UART peripherals. We also have device reset, message sharing, and debug interrupts connected up to the PLC. The watchdogs for each heart can also generate interrupts, for example if they time out. We also have some alert interrupts, for example the voltage alarm, interrupts for the Athena core, and some more UltraSoC debug interrupts. We also have several interrupts from the fabric into the MSS, which can be enabled from the MSS configurator. If we open up the MSS configurator, let's create a new project and call it Test. In the Miscellaneous tab, there's an option to expose interrupt ports to the fabric. This will expose 64 interrupts from the fabric to the MSS. This allows you to have fabric components generate interrupts to be handled by the MSS. All of these interrupts are contained and handled by the PLC, and if you scroll down to the bottom of the MSS plic.h file, you can see the different functions that can be used with the PLC. These can be called to configure the PLC to handle interrupts in different ways. For example, you can individually enable and disable interrupts on different hearts. You can also reconfigure the priority of interrupts so that different interrupts have higher priorities than others. And you can also check the priority of an interrupt. You can also see the functions used during the different stages of handling interrupts, such as claiming and completing the IRQ. Finally, you can also set the threshold of an interrupt.